Hi there, Pre-Calc gang. Time for another online lesson, this time on 2.6 Systems of Linear Inequalities. This is again a pretty short lesson, ties in really well with lesson 2.7 and the linear programming project that you're going to be doing in this class as well. First of all, let's just start with some basics. If you remember last chapter we graphed some inequalities, and the key thing there is anytime you graph inequalities there will be some shading. Remember we graphed a line and then we had a test point. Typically that test point was 0, 0, but we had a shade on either side of that line to indicate the whole solution set. Now in this chapter, when we talk about systems, we had systems of equations and now systems of inequalities. Again, anytime we have the inequalities it'll be some shading, but really now when we look at our final answers it will not only be shading but shared shading. So there'll be a couple different regions that are shaded and we have to look at what is shared or what is common. And then notice this vertex theorem which says the maximum or minimum value of a given function occurs at a vertex of the polygonal boundary. By a vertex we mean a corner point. So in addition to this shared shading, we'll have to look at these vertices or corner points to determine maximums or minimums. So we're going to really basically just do one example here, and hopefully that'll be enough to get you going, and then we'll work on it, of course, more in class tomorrow. The example that we're going to take a look at, it says find the maximum and minimum values of this particular function for the polygonal convex set. That's kind of fancy words, meaning it's when we do this shading here and look at the shared intersections, it's going to produce some kind of a region here that has some corners. That's what we mean by a polygon. And a convex set means it's going to be enclosed. So anyway, we're going to graph each of these inequalities. We'll use a different color for each one so you can see what's going on here. And I won't really do all the shading until the very end because otherwise it does get a little confusing. First of all, x is greater than 0. We use a red shade for that. Well, that would be anything to the right of the y-axis, basically, when x is greater than or equal to 0. Technically, then, we would have a solid line here on the y-axis because of the greater than or equal to sign. Next one we want to take a look at is y is greater than or equal to 0. And, of course, that would be anything above the x-axis. All those y values would be bigger than 0. Next ones then, of course, are just a bit trickier. Here we're actually graphing a little line. So 2x plus y less than or equal to 4. I'm going to make a little chart for that one. I like to make these little charts when they're in standard form like that. So if x were 0, y would be 4. Again, I'm kind of pretending this is an equal sign. And if y was 0, then x would be 2. So I'm going to plot these points 0, 4, and 2, 0. I would connect those up like this. And if I actually did some shading then, it would be shaded to the left like that. Okay. Now already we can see that if we look at the intersections of those first three regions, it would be this triangle right here. Okay, and lastly then I'm going to look at the last little inequality here, which is x plus y is less than or equal to 3. Again, I'm going to use my intercept method, so that would be 0, 3, and 3, 0. So I put my dot here and here, and sure enough, if I connect those up, then it's going to look like this. Again, the shading would be to the inside, to the left, because of the less than or equal to sign. And what we'd really have, I'm going to change colors here so you can see what the final region is, where all of these shadings intersect. I think you can see would be right in here, wouldn't it? Okay, and I can even color this pretty nicely. Look at this, how nicely I can color here in between the lines. And so this is my convex region here. Now the points that I'm going to check then, that I need to test, remember according to our theorem on the slide before, it's these corner points that I want to test, and I want to test it in this actual function right here. So it looks like it's the points 0, 3, 1, 2, and 2, 0. So 0, 3, 1, 2, and 2, 0. Technically, I could also check this point here, 0, 0, but that's not going to really maximize or minimize anything. All right, so I'm going to go to the next slide, and I'm going to try to remember those points there, which are 0, 3, 1, 2, and 2, 0. Is check those points. I'm going to get a different color here once again. I'm going to check those points in this particular function. As we'll see when we talk about linear programming, this is often what we're trying to maximize or minimize, things like that. All right, so we said we have the point 0, 3, and 1, 2, and 2, 0. And I'm going to substitute these values again in this particular function right here, and we want to see what's the biggest and smallest it can get. So if I put 0 in for x and 3 in for y, it looks like I'm going to get 7 for that point 0, 3 up here. For the point 1, 2, I'm going to get, let's see, 2 times 2 is 4, 5, 6 for that point. And for 2, 0, I'm going to get 2 and then 0 there. Looks like I'm going to get 3. So then the maximum and minimum, I just have to say that the maximum value is 7. And then the minimum value, of course, is going to be 3. And they'll have a little bit more specific meanings as we get into our linear programming, but it's going to be this type of idea where we're going to graph some inequalities. Again, the shading is the key thing. I'm going to find those corner points. I'm going to test those corner points in a function that they give us to look for a maximum or minimum value. All right, nice job today, everybody, hanging in there, and we'll see you in class. Bye now.